covering the help sheet, and we're just going to look at the trigonometry section. So if we scroll down to the trigonometry section, right angle triangles at the end here, let's look at number 1, part I. If A is 51, all we have to do is hit tan 51. Instead of A, we're writing down 51, so tan 51, and your calculator should come up with 1.23 to 2 decimal places. Mind you, you've got to remember to look at the third digit. If a third digit after the 3, if the third digit is 5 or more, you've got to round it up. Alright, if the third digit there is 4 or less, then you just keep it and just chop off everything after the second digit. So there's only 2 decimal places left. Right, next bit here, got cos B. Instead of B, you write 55, because B is 55, and when you write cos 55 on the calculator, you should end up with 0.57 to 2 decimal places. Sin C is 0.4567. Now what you have to do here is we're actually not given the C value, we've got to figure out the C value. It's actually a reverse process of these last two here. In the last two we were given the A and B values. Now we've got to figure out the C value, so this is the opposite. We've got to use the reverse of sine, which is sine -1. On your calculator, you just hit the shift key and then sine. And then you type the number 0.4567, the number that was on the other side of the equation over here, and it should come up with the angle, the C angle that you're trying to figure out, which is 27.17 degrees. Alright, next bit over here, the length of a side labelled X. If you're looking at a triangle where there are no angles given or no letters in the middle of a triangle, you need to use Pythagoras. So when you're using Pythagoras, we just have a big square root over the other two numbers that are given, and you square those two numbers. So we've got square root of 8 squared plus 9 squared. In some cases we have to use minus instead of plus, but if we just use a little bit of common sense here, we're looking for a long side, which is x. It's a missing side is our long side, and obviously you've got to use plus to get something that's longer. So our answer is 12.04 to 2 decimal places. Next question over here. Number 3, calculate the length of a side labelled Y. Now we're looking for a shorter side this time, and once again, if you just look in the middle, there's no angles given except for the right angle. Now just ignore that, but you need to have a right angle. But there's no angles given in the inside, and there's no letter in the inside. If that is the case, then you immediately use Pythagoras. You use the square root. So square root of, and then the two other numbers that are given in the middle of the square root. Now, in this case, I've used minus because we're looking for a shorter side. Obviously, if you want something shorter, minus is going to give you a smaller number, right? So it's a bit of common sense here. Minus will give you a smaller number than what you started with. So we're looking for something shorter. We must, shorter side over here, it's definitely shorter than at 21. And it's, you know, sometimes even if it's a medium side, you have to use minus as well. Alright, only for the longest side you would use plus. But we're looking for a shorter side here, use minus. So 21 squared minus 19 squared. Also a little bit of common sense as well. You've got to subtract the shorter side from the larger side. So start with 21 squared minus 19 squared. If you end up with an error on your calculator, it means you've probably got these two numbers around the wrong way. You're minusing them around the wrong way. Right, so try putting it around in the other way if error comes up on the calculator. The answer is 8.94 centimetres to 2 decimal places. Number 4, calculate the length of a side labelled J. Right, for this one here, we're given an angle in the middle, so immediately you know not to use Pythagoras. Do not use the square root, because there's a reason is because we've got an angle given in the middle of the triangle here, 31 degrees. Alright, so we've got to actually label these sides if you can. Now I haven't labelled them, but we've got O over here. This is the opposite. J over here is in fact the opposite of 31. So that's our opposite. We leave this one blank if it's blank. And we've got 10 meters over here. That's our hypotenuse, our longest side hypotenuse. So we have the opposite J and our hypotenuse, which is given O and H. O for opposite, H for hypotenuse. O and H, this O, if we look down here, O and H are in SO. If we think of SO, ka, toa, so 3 things that you've got to memorize. SO, ka, toa. Well, the only one out of SO, ka, toa that has O and H in it is SO. O and H there. So what we use is sine 31, sine of the angle, always follow it by the angle, equals, always put an equals sign in there, equals the opposite, and in this case opposite O is in fact J, opposite the angle 31, but which is J over here, so put in J, and then we've got the hypotenuse, which is 10, so we'll put that in there as well. So S, O, H, think of reading it across and then down. S over here, O and H, that's SO, if we read it across. And what you have to do is move this 10 across to the other side, so you're left with J by itself. Divided by 10 on this side becomes times on the other side. So think of this 10 being erased here, along with a divide, and then you're putting it over here as multiplying over here. There's no times in there because in algebra times is invisible, but we're going times 10 here on the other side, and we're left with just J by itself. So we can work out J. We can put that into the calculator, 10 sine 31, and this will be our answer, 5.15 meters. Now, just very quickly, some people have learned a different method of doing this. Alright, so if you've learnt the magic triangle method, then just listen for a minute, otherwise ignore what I'm about to say. But there is another way of doing this, and we can look and see that our unknown is in fact our opposite, which is this O here. And if we just cover up that O, let's think of covering it up with your hand. We've got remaining, we've got sine and H. And when they're down the bottom by themselves, you're just multiplying. So we've got sine of the angle times 10. Alright, so sine 31 times 10, or 10 sine 31, if you put it around the other way, okay? So that's just another way of doing it if you use the magic triangle method. Alright, let's scroll down to the next one here. Number 5. Calculate the length of a side labelled K. Now K is in fact adjacent to the angle given 43 degrees. Now realise again, we do not use Pythagoras like we did over here. Why don't we use Pythagoras? Because there is an angle. When there's an angle in the middle, we don't use Pythagoras, we use SOHCAHTOA. So we need to first label the sides. Now K is given, that's our adjacent. Next to the angle means adjacent A. So think of A there. and then our longest side, 3.2 meters, is our hypotenuse h. So we've got A and H. And out of SOHCAHTOA, the only one that has A and H in it is Ka. Look over here, C-A-H, Ka. So if we then write up this Ka thing here, we've got C, A and H. Cos of the angle given, 43 degrees, equals, make sure you put the equals in there. Now we have to do the A. Now the A value next to the 43 degrees is in fact K. So instead of A, we will use K. And then H, so C, just think of a C, A, H down the bottom. Okay, now our H value, the longest side over here was our H, and instead of H we've written 3.2. Once again, you can move this 3.2 over to the other side and erase this divided by 3.2, becomes times 3.2 on the other side. So we get 3.2 cos 43 equals K. Now all you have to do is put that into the calculator and you'll end up with the answer K equals 2.34 meters. Mind you, you should always check to see whether this actually makes sense or not. Now look, we've got our longest side of 3.2 and we're really expecting something that is slightly less. Maybe, you know, this looks about 2/3 less, doesn't it? It looks about 2/3. Is our answer about 2/3 of the original number here? You know, if you get a ridiculous answer, you get 7. That could not possibly be 7. And it couldn't possibly be 0.5 either. It's far too small. It's going to be a little bit less than this 3.2. Just check your answer, see if it actually makes sense here. 2.34 sounds about right. It's likely to be correct then in that case. You haven't made a mistake. So you can just check everything. We could go back and just have a look at the other one over here, but mind you, got a lower angle here of 31, 10 meters. Well, I would expect with a low angle there that this side here is relatively short. So it's a narrow angle here, making the triangle narrow, making this a lot less than this long hypotenuse. You know, you think it would be at least a half, or around about a half or so. It could be less than a half, but anyway, we've got our answer as about a half, 5.5 meters. And so it's likely to be, it's half of a 10. See, let's look at the length of a 10 there, and this is about a half, or approximately anyway. So our answer is likely to be correct. You know, it's just a good way of just checking to see whether your answer is self-checking to see whether you've made a mistake or not. Okay, so those answers are correct. Let's go down. Scroll down as far as we can here. Okay, so next one here. Calculate the length of a side labelled M. Now, first of all, we've got to label things. So, and first of all, mind you, we notice that there's a 14 degrees in the middle here. Now, there's no little angle here, but we know it's an angle because of the degrees symbol there. It's an angle. All right. So immediately, we're not going to use Pythagoras.